you're going to download these data sets, okay? And what we're trying to do here, okay, it's important to understand the overall goal. We have this mantra that samples estimate populations. And it turns out it's not just sample statistics that estimate population parameters. We're also trying to estimate the distribution. Is there anyone that doesn't know what a distribution is? Everybody? If I put that on an exam, everybody knows?
I don't know.
Okay, so here's what a distribution is telling us, okay? And the book uses this a lot, and it's a term that they kind of assume you know, but we probably shouldn't really assume that. This is a plot of data, and this data is a gazillion SAT critical reading scores, and I don't know the origin. I have the data set, I don't remember the source. And so you can see that here we plotted a histogram, right? Okay. And what we're trying to do is we're trying to estimate what the population distribution looks like. And so what is a distribution? A distribution is associated with a variable. And what it does is it tells us the range of values the variable can take on. So if you look at an SAT score, it can go from 0 up to 800. And it tells us how likely it is to take on each of those values, okay? So you can see, for example, you're relatively likely to get an SAT score of around 520, 540, because there's a lot. The bar is really high here, right? Whereas it's not so easy to get an SAT score roughly 800 or so, right? Okay, so that's what a distribution is. And what we're trying to do is we're trying to visually estimate this curve for the population. When you do a histogram in your mind's eye, you want to try to fit it to a curve that kind of cuts through the data evenly, okay? And you can see it's not a perfect process, right? I mean, there's gaps and all this sort of stuff. But again, this is kind of a rough sort of thing visually. The last thing we want to do is we want to describe this population curve, okay? We're actually describing the data set we're looking at, but implicitly we're thinking this is what the population looks like. And so this is our mission should we choose to accept it. What we're going to do is we're going to use this exploratory data analysis. This is exactly the same process that we talked about with categorical variables, right? And in fact, it doesn't matter what the variable is. It can be anything. We do the same thing, right? So first we look at the data, we inspect it, we clean it if we have to. Then we visually summarize it, that is we plot. We numerically summarize it, we compute summary statistics. And finally, we describe the whole gamish, the whole thing. Put together the visuals and the numerical. Now, what's challenging is quantitative is considerably more complicated than categorical, which is why we introduced categorical first, because it's a walk in the park. We have to deal with outliers, okay, which we didn't have to deal with in categorical. There's 3 different types of plots, and you might say, oh, we had 4 with categorical. That's true, but they're plotting the same thing. And it turns out these 3 plots are qualitatively different. We're not looking at the data the same way. The plots have a lot more information. Again, the numerical summaries are much more involved, okay? There's more of them and they're more involved. And finally, and I don't know where to put you guys. I want to see the class, and yet I have to see the screen. So it's kind of a juggling act. There are 5 things that we have to report. Okay? And this is super important. So one of the places where students go wrong is when I ask you to describe a data set, people just go freestyle. Okay? These are the 5 things we always report. And so what we want to do today is we want to learn, okay, how do we do those things properly? How do we interpret what these 5 things represent? And that's really important, okay? And then we'll want to understand why they're important. So one of the things you want to take away from statistics, and this is an important general kind of observation, there is nothing we do in statistics that's not applied. And there's a reason why we do everything. So if you're ever doing this and you're like, what in the hell's going on? I have no clue why we're doing this. See me. There's a certain logic that goes behind this, okay? And this course is really devoted to kind of fleshing out that logic. Okay, so what we're going to do is I'm going to look at a few real data sets. We're going to see how to do each of these 4 steps with each of these data sets, and it's going to illustrate some key concepts. And this is going to be new. Even if you've read the book and you're spot on and you've done the homework, there's going to be new stuff in here because this data analysis is involved, okay? It requires some practice. So the first data set we're going to look at is this data set called heights. And just really brief context, okay? This is a famous data set. It's very large for its time, collected way back in the 1800s. And it gives, and this individual was interested in what we would now kind of call eugenics. He was interested in trying to understand human factors, okay, in a quantitative way. And what he really wanted to do is he wanted to see if there was a relationship between the height of the father and the height of the male child, among other things. We're going to look just at the height of the male child in this data set. Okay, so what I'm going to do is I'm going to go over to StatCrunch, where I have this data set. Now I got to move this bar. And you guys should have that loaded up. And even though I put it to be really dramatic and highlighted text and bold-faced letters in the announcement, I really will assume from now on that you have this stuff ready at the start of class. It takes too much class time to be doing this, okay? So first thing I'm going to do, what's the first thing we do with a data set? Always. We look at it, right? We don't put it into a computer. We look at it. So I'm going to sort, okay? And we go ahead and choose the male child. That's what we're interested in, okay? And so this is the height of the male child. So this is 60 inches is what, 5 feet? So that's reasonable, nothing strange there, right? And we go all the way down here. And let me try to get to the bottom. I'm going to have a hard time getting to the bottom because I got too many windows open, I think, here. Here we go. And the last one is 73.2 inches. So that's 6 feet 1.2 inches. So we don't have any, what are we looking for here? We're looking for invalid data values. So Gerard, tell me an example of an invalid data value. You're looking through male heights. What would be an invalid data value? I could ask you this on the exam.
An example of an invalid data?
Yep.
I don't have the data up right now, but I can say that an invalid data height would probably be a height that's like, I don't know, what is this calculated in, centimeters?
Inches.
Inches. Probably like an outrageous number, like maybe like 12 inches, something like that.
Right, something that's not humanly possible, okay, or a negative number, okay, something like that. Okay, so we don't have any invalid outliers. We're going to wait on outliers, okay. Sometimes outliers are apparent. You look at a data set and everyone, if you look at that Babe Ruth data set, right, it's like 1 to 19, and all of a sudden 54, okay, all of a sudden Babe Ruth, obviously it's an outlier. We're going to talk about how to identify outliers. It's a little tricky. Do we have any missing data values? No. So our data is pretty good. Okay? Galton was a pretty good statistician. He done good. Okay, what do we want to do next? We want to plot. What sort of plot should we make here? And why? I have 3 choices, right? So if I'm using a small data set, we do a dot plot, okay? And what is small? You know, it's kind of relative, about 90 data values or less, okay? Somewhere in that ballpark. We have a huge data set. How many data values? Like 700, right? We're definitely not going to use a dot plot. Generally, we use a histogram. And the reason why is a histogram tells you stuff that a box plot does not tell you. And so here's how you want to think about these plots, and this is important. If you think about level of resolution, this is a extremely high-res view. okay? This is like somebody taking a picture of your face and they're literally imaging the pores. They can image everything, okay? This is medium res. And that's normally what we want. And it isn't just because it's medium resolution. We're gonna see there are other reasons also, okay? And this is actually low res. This is like somebody zoomed out from the earth, okay? And they're looking at the world, okay? Almost always we want to do a histogram. And the two exceptions are when we want to analyze symmetry and outliers, we do a box plot. So let's go ahead and make the histogram. So we go to graph, histogram, height of male child. You can plot frequency or relative frequency. It doesn't really matter, okay? And this is where you want to pay attention. So a couple of things I usually do. I put markers for the mean and the median. And what that means is it's going to put little lines where those values are. It'll put a green line where the mean is and a red line for the median, okay? And the last thing I'm going to do is I'm going to put a title in and labels. On your exam, you have to have, if I ask you to do a plot, you have to have access labels with units. You have to have an appropriate title. It should be a good title, okay? So I'm going to say, distribution of heights of male children. And the X label is going to be height. And again, Gerard asked an excellent question. He said, what were the units? Really important, okay? And that's one of the things I'll tell you if it's an outlier. If these were in centimeters, I would have a problem, right? And whoops, I put the X. I'm used to using software where the title comes first, sorry. And if you use frequency, you can put frequency or counts, okay? I'm just gonna put frequency, counts, number of, all that's fine. And we're ready to go. And there we are, all right? Now we've done the plot. So now we want to describe the plot, okay? Now, there's some things to think about with histograms, and this is important, so I want you to listen carefully. And Mason, I'm going to ask you, because you asked this question yesterday. What's going to be the challenge here with this plot?
Probably like the modes, seeing like how many modes it is and if it's symmetrical or skewed or not.
Modes is going to be a real issue, okay?
Yeah.
And this is a non-trivial case because generally what happens is you have little fluctuations, okay? This bar, you can argue or not whether it's a little fluctuation. It's going from 80 to over 120. So there's a lot of things here. So here's what we do. We replot the histogram and we mess with the bin width, okay? So one of the things that you want to know with a histogram, I did not mention this in the lectures, okay? But with a histogram, you always want to have at least 6 bins. I'll put this here. Minimum of 6 bins. If you have less than 6 bins, you really can't see what's going on with the data. So what I'm going to do is I'm going to do a really quick calculation here, okay? My data goes from 60 to 80. These look like these are in ones, right? From 60 to 65, it looks like these are ones. So I'm going to rebin these. And here's how we rebin it. You go to bins. I'm going to start at 60, and I'm going to make the width 2. And here's the reason why. The bins are too small. What's causing those fluctuations most likely is not the differences in the frequencies. It's just how these things are being binned. Watch what happens when I replot it. Okay? Now you can see it's unimodal. Okay, so this replotting is important because if you don't, you're going to say it's bimodal, and I'm not going to give you credit. Okay, I'm telling you right now, you have to rebin these things. It's very important. Okay, you can clearly see this is unimodal. Now, you might say, oh wow, it's so arbitrary. No, it's not. When you get everything right, everything holds together. Okay, so notice I can kind of see a nice curve through here. Okay, so we know now that this is unimodal. Remember, and I'm gonna go ahead, I'm gonna copy and paste the histogram in here real quick, okay? You can just right click and do copy image and just paste it right in. If you go to edit, there's an option also for doing it, for copying, but it'll just tell you to do the same thing. And there we are. So on an exam, I could ask you to make a histogram and plot it, and you should have everything on there except the mean and the median. I don't care about that, okay? But it should look something like that. Okay, now I want to describe the plot. So the first thing I have to do is I have to describe, there's a couple of things I want to describe. I want to describe the shape. So I want to describe, let's see, I want to describe the, we'll say number of modes. So this is going to be unimodal. I want to describe its shape. So who wants to take a shot at the shape? Shot at the shape. Kayla, do you want to try?
I don't know.
Do you remember what it is we're trying to discriminate between?
No, sir, I don't.
Okay, so remember that picture from the PowerPoints, okay? Let me bring it up really quick if I have it. We're trying to distinguish between symmetric and skewed, right? Let me bring it up really quick here.
Would this one be symmetric?
So right, so skew means it has a tail, right? So the question is, does this have a tail or is this symmetric? And this is not quite so easy. You might think it might be left-tailed because if you follow my cursor, it's kind of going up and then kind of down like this, right? So it might be skewed. What might make you think it's symmetric? There are two things. Okay, those things that I plotted on here, right? It was the mean and the median. You only see one bar. Why is that? They're literally on top of each other. So when the mean and the median are really close to each other, is that evidence of symmetry or skew? Symmetry. Okay, so there's two things that will tell you symmetry. First of all, you can look at if the mean is close to the median. In this case, it's literally on top. But there's another way too. Sometimes you're making these plots, and it really is hard. It's genuinely hard. And this is when you make a box plot. Okay, so let me show you. I'm going to make a box plot here, and I'm not going to bother to put in all of the other junk I need. Okay, and I'm going to go ahead. Put the mean and the median. I'm going to plot it horizontally, so you have to click this special box. And notice these are two views of the same thing. And let me try to put them in the same panel so you can see here. Kind of smushed a little bit. I'm going to put them on the same scale. Okay? Does the box plot make you think this is symmetric or skewed? Well, here's what we're going to do. Here's what we're looking for, okay? We're looking to see if the median, which is that thing in the middle, and in fact, let me take out the mean and the median here, because the median's already on there. So the median, which is the center bar, notice it's in the middle of the box, okay? So that's evidence that it is symmetric, okay? In other words, 25% of the data is in the lower portion of the box, 25% is in the upper, okay? The other thing we look for is the whiskers. When we have a skew, when we have a tail on one side, the whisker is longer, right? You don't see that here. These whiskers are relatively even. So this is strong evidence that this is a relatively symmetric data set. Notice one of the things that's throwing you off are the outliers, okay? The outliers are making it kind of appear that there's a tail here and there isn't, okay? So this is definitely symmetric. We can also plot a box plot, Okay, these are the two things we can do to determine the shape. And in our case, we can see that, in fact, it is unimodal and it's symmetric. So I'm going to go ahead. I'll put this up here. And this is symmetric. Notice this is why this is why it's called exploratory data analysis, right? You can't just look at the data and tell this. You really have to play around with it. The last thing I want to look at is outliers. And this is one of the ways that a box plot is actually bad. Where are the outliers on this plot? Who wants to tell me? David, you want to take a shot?
Yeah, so, sorry, so for the top plot or the?
So this bottom plot, this is a box plot, right? And the outliers are data values that are really separated from the rest. They're kind of like outcasts, right?
So you've got outliers in both directions. Yeah, anything really outside the whiskers.
Exactly. So this is how StatCrunch indicates it. So we have one lower outlier and three upper outliers, but they're not actually outliers. Okay. What they are, and this is where the histogram is useful, is they're actually the end of a long tail. So sometimes people call these outliers in name only, meaning they're outliers just because they fit a certain criterion. But in practice, in reality, there aren't any outliers. So if you look at this plot more carefully, you can see if this was an outlier, how would this appear on a histogram?
Maybe like in the end, it's like too high or too low.
Right, and I'm going to put a little finer point on what you're saying. Remember what an outlier is. An outlier is an outcast. So what would happen with an outlier is it would actually be separated from the rest of the histogram. You would see a gap, a big gap, okay? And you're not seeing that gap. This guy's not outcast. He's on the outskirts, okay? But he's not an outcast. So we have no outliers here, okay?
So if it's like a continuous graph, then it's not an outlier.
We can have outliers with continuous data. Let me show you an example of an outlier. Do you want to see an outlier? Yeah, of course
Yes.
you do. Of course, everybody does. Okay. This is an outlier. The home run data set. If you go to, this is a real pain to do. If you look at the home runs for 1920, okay, and you don't have to plot this. I'm just going to do this really quick, okay? And we go to home run, and I'm going to group by year. This is the year 1920, okay? There is one outlier. It's out here, okay? That's an outlier. And in fact, you can't see it because it's a single data value, okay? It's so small, you can't even see it. But it's here. This is Babe Ruth. He has 54 home runs, okay? That's what an outlier looks like. There's a big gap between the rest of the data and the outlier, all right? Okay. Everybody's good? This is making sense?
I'm just confused about like making bins. Like, how do you know how much bins you should make?
Excellent question. Very good question. So let me show you. Okay. So it's a little bit like the Three Little Bears, okay? I'm going to make the bins too small, and you're going to see what's going to happen. I'm going to make them 0.5, okay? Notice it's too choppy. Too many up and downs, right? That's 0.5. Now I'm going to make it 0.1. I'm sorry, I'm going to make it 1. If I made it 0.1, I'd make it worse. Notice it's a little smoother. What am I trying to do? I'm trying to fit this histogram to a nice smooth curve. Let me go back to the PowerPoint for a minute, okay? Here it is right here. The goal is I want to fit this choppy thing to a nice smooth curve. All right? So I'm gonna just put you guys on the side here. I think this will work. So if I make it a little bit bigger, so I'm thinking, okay, this is choppy because the bins are still a little too small, and now I make it 2, it's gonna look pretty decent, okay? Now you can fit this with kind of a nice smooth curve, okay? So the answer is you play around, okay? Till you get something that looks like you can fit it with a nice smooth curve. And I could play around a little more, but this is probably good enough.
I have a question.
Yeah.
So I know earlier when you were asking the question about is this graph symmetrical or describing the graph, I'll be really honest, I haven't gone through the book yet to learn how to what the different types of symmetrical versus not, but one more time, how do you identify if it's symmetrical or not?
Okay, so what you're trying to do is you're trying to distinguish between skewed and symmetrical. So let me show you just really quick. I'll pull up the class notes here just really quick. Let's see. Because you may not be the only one, and it really helps to do that work before, of course, but that's okay. Let's see. Oh, I put it in readings. Yeah, go back. Whoops. Okay. So here's what I'm trying to distinguish between. Let's see, this is the PowerPoint is. And let's just skip through these. Okay. So these are the 3 alternatives. Okay. And what you're seeing and what you're seeing with left and right skewed is the data is bunched up. Okay. And so if you go back, so let me kind of show you what a histogram would look like with the Babe Ruth data. Okay. If you do the Babe Ruth data, and you guys don't have to do this, I'm just going to do this really quick, okay? Just so you can see. You're going to see that this is how the box looks, okay? And you can see that you can see the asymmetry. In fact, you can't even see the median. You can't see the center of the data set because it's the same as the first quartile. So all the data you can see in the histograms bunched up here, and you're seeing that. And then you have this long tail, and that's causing the whiskers to be asymmetric. And in fact, you don't even have a whisker on the left-hand side. The data is so extremely skewed, okay? And that's what you're looking for. Whereas if you go back to heights, you can see that the distribution of the quartiles is very similar, okay? They're on both sides. You're not seeing data bunched up on one side or the other. And that's what the box plot's telling us. Okay?
Thank you for showing me. I'll go back and review that.
Okay, great. All right, so we know that it's symmetric now. We know that there are no outliers. That's really important, okay? If there were outliers, what would we do? Well, we'd have to think about it a little bit. It depends on why they're outliers, okay? Let me go to the last one. So outliers, no. All right. And so the last two things we need is the center and the spread of the data set. And so I'm going to go, I want to show you this with the center and the spread. I think it's in the previous handout. It is. So with the center and the spread, I'm not going to go back to the other handout. With the center and the spread, here's what we know. There's 2 measures for the center, the median and the mean, okay? When we have strongly skewed data or we have outliers, we use the median. And that was what we were talking about in the introductory video with Mr. Burns. That's what he was doing. He had an outlier, okay? But yet he was using the mean. He was using the wrong measure for the center. So we use the median when we have strong skew or outliers for the center, and for the spread, we use the interquartile range. That's the length of the box in the box plot. With symmetric, we use the mean for the center, the standard deviation for the spread. So here I have a symmetric data set, so I'm going to use the mean and standard deviation. And we're going to do that with StatCrunch. We don't do any computations by hand practically ever, okay? So we go to summary stats, column, height of male child. Now the default is that all of these are selected, and that's way too much, okay? I'm going to click on the sample size. That's usually a good thing to have. I'm going to hold the control button and click mean, and while I'm holding down the control button, click the standard deviation. And these commands are also shown in the videos, okay, the summary videos. And there we are. So we have a mean height of roughly about 69.2. And you can copy and paste, which will help you a lot on the exams, okay? It'll save you a lot of time. So our center here is the mean, and its value is 69.2. And the spread is a standard deviation, and it's about 2.63. How many decimal places depends a little on the application. I'll always tell you on an exam, okay? Standard deviation, and its value is this. And of course, we should put units, okay? Next person would be like 69.2 what, okay?
I have a question, Professor.
Yeah.
Those are just the two ways that we're going to talk about the spread, right? Just using the IQR or the standard deviation in this class?
Right, and there are other ways. So for example, the range is another way that people use. There's a reason why we never use the range. And the reason is because what we don't want, okay, so here's an excellent example. Go back to the Mr. Burns example. In fact, I'll show you the data set, okay? This is the data set for Mr. Burns. I'm gonna open up a new thing here really quick. So we had 9 people that made $1, right? And he made $991. All right. Now, let's look at these 3 ways of doing the range. I'm sorry, of doing the spread, okay? So I'm going to look at the standard deviation. I'm going to look at the range. And I'm going to look at the IQR. Oh, duh. And you notice that these guys are, I'm sorry, well, okay, that's all right. So notice here that the IQR is 0. Okay, that's indicating that if you made a box plot, the width of that box plot would be 0, okay? The range is 990. Notice what's going on. This one outlier is throwing everything off. Let me do the following. I'm going to go ahead. I'm going to copy this in this column. I want to show you this because this is an important point. I'm going to analyze the same data set, okay? Summary stats. I'm going to choose it this time. N, standard deviation. So this is an excellent question, okay? Because you might say, well, you know, maybe it really is 990, right? So here's what I want you to notice. I left out one data value. Notice how standard deviation and range change drastically, right? IQR remains the same. So we want the measures for the center and the spread of the data set to be robust. In other words, these are supposed to estimate the population. So they shouldn't be sensitive to a single data value, right? Does that make sense? Yes, yes, no, maybe? Okay, so this is why we use the IQR. The IQR is resistant to outliers and it's resistant to skew. In other words, the really extreme values are not going to affect it a great deal. All right? Excellent question. Other excellent questions that we have.
Thank you. So you're saying we don't use range because one value could affect it?
The range of all the values is the most sensitive because it uses the most extreme values, right? And so an outlier totally throws it off, okay? And the standard deviation gets affected because the mean moves out. And you remember what the mean is, I'm sorry, remember what the standard deviation is. It's the average distance from the mean, okay? So as the mean moves out, the standard deviation inflates the width a little bit. But you're absolutely right. The range is the worst because it uses the worst two values, the most sensitive, right? Okay, so now we're ready for the coup de grace. I want to describe the plot. I'm going to put these two pieces of information together. I'm just going to copy and paste because I'm lazy. And I'm ready for my description. So here's how we describe this. This isn't the description, by the way. This is all the information I need. So let's see. I'll put a little. I'll do this in the table. So we'll say the data is unimodal, symmetric, with no apparent outliers, okay. If there were outliers, you can just say with outliers. Generally, what people do is they say the number of upper and lower outliers. Okay, so like in that example I showed you. Oh, actually, we can't use that. So in the Babe Ruth example, we would say one upper outlier, and then sometimes people give the values. I'm not going to be really picky about that, okay? The center is given by the mean, which is 69.2 inches. And the spread is given by the standard deviation, which is 2.63 inches. Okay. You can use that literally as a script. Okay? And I would actually prefer you to. Rarely in this class do I tell you you have to do something a specific way. This is one exception, okay? It's just good to stick to the script. And that's it, okay? I've described the number of modes, the shape, the presence of outliers, where the center, and where the spread is, all right? And you can actually give someone a description. If they understand what these terms statistically mean, you can kind of give them this, and they can get a little bit of a picture of that in their mind, okay? Questions? Anything that I went over too fast that you're going, holy cow, what the heck was he talking about? Well, that's a first. Okay. Should we start another example?
Yes.
Okay. So let's try another example. So the next data set I had was Craigslist housing data. So this actually came from a friend of mine who was visiting here to do research, and he wanted to know what prices are going to be like. He was here short term. And so I collected this data off Craigslist a couple years ago. And we're not interested in heights of children. We'll say costs of apartments, okay? How's that? Okay. So this is our data set. First thing I'm going to do is I'm going to sort it. So I'm going to find price here. I'm going to sort this. You know, I might want to look a little bit at what these things are. Like, for example, if there was something that was not, maybe not in my population, okay, but I'm not going to be that picky right now. So I'm going to go ahead and sort. Price. Okay, so I see that the lowest value department's 500. That's possible. I don't know where that would be at, but it's possible. And the highest is 2,000, which is definitely possible in Daytona Beach. Okay, so we don't have any invalid data values, nothing that seems like an outlier, and we don't have any missing data values, right? So I can just take this. That's okay. I'll just type it in. So none, none, and none. Okay. If I had missing data values, I wouldn't really do much about it, okay? There's nothing I can really do about it in this class, so I wouldn't worry about it. Okay, ready to plot? I'll go ahead and make my histogram.
Quick question for
Shoot.
as far as the missing data values, is that just price, or what else would you consider a missing data value for?
Okay, so that's actually a really good question, because there is a lot of missing data here, okay? I'm just focused on price, but you're right. If I was looking at another variable, and what it would actually depend. So if you were doing this in real life, okay, what you'd actually do is you'd think about all the variables you're interested in, and then you would think about, well, are these Google ratings going to mess up my analysis, okay? And if they were, if I wanted to do a study where I'm studying the relationship of Google rating to price, I would have to then delete all the rows that don't have Google ratings. But in this class, we're going to look just at one variable, so we don't have to worry about the rest of the data set for now, okay?
All right.
It's an excellent question. Okay. Histogram, I'll do price. You don't have to put in the mean and the median, okay? Sometimes people like values above bars. It is kind of nice, okay? It's not a huge deal. X label is going to be cost, dollars USD. And, well, actually, USD is kind of redundant, right? It's kind of like ATM machine and frequency. Okay, title, I'm just going to put distribution of apartments advertised on Craigslist. And I'll put the year, because that is kind of relevant. Okay. And we're pretty much done. And there we are. Okay. So that's a nice little plot.
I have one quick question again.
Sure.
You said the y-axis is always going to be something like frequency or count or something like that, right?
You can do whatever you want, and honestly, I don't really care a great deal. I think counts are better, so I'll actually show you. I'll show you the difference. If I do relative frequency, and notice this is actually counter to the rule. When we did categorical, we said large data sets always use relative frequency, always use percentage, right? But notice that this is actually a little bit harder, and for some reason it took off above the bar. Hold on. So you guys asked really good questions. I hope the other section watches your video. Okay, it is value above bar. Why isn't it putting it? Okay, well, in any case, here's the issue. I would really like to know how many's in here, okay? And it tells me that the relative percentage is 0.008. And so it's a little better to have counts here, okay? But honestly, to me, it's 6 of one, half a dozen of another. You can use either one, whichever you like, okay? However, let me add one thing, okay, just so no one's confused. That is not true for categorical variables. For categorical variables, there are strict rules for when we use frequencies and when we use percentages, okay? Large data sets, we always use percentages. The thing is, we're looking at different things with these two plots, and I want to say something really quick. And this is important. Notice a histogram looks like a relative frequency bar plot, right? And the book actually calls it actually calls a plot of a histogram a relative frequency bar plot. The book has a lot of mistakes in it. They are not the same. Okay, this is one of the ways in which they're not the same. They look the same, but they're very different, very different. Okay, unimodal, bimodal, heptamodal, what do you think? How many modes?
I say unimodal.
Right, I'm trying to have this nice, can you guys see my cursor as I move it here like this?
Yes.
I'm fitting it through this nice curve, clearly unimodal. Right skewed, left skewed, symmetric. What do you think? Somebody new. Let's see. I'm going to call on who haven't I picked on today? Hold on a second. You guys are over here. Let's see. Let me pick on someone here. Rachel, what do you think? Looking at this plot, is it right-tailed, left-tailed, or symmetric?
I think it looks right-tailed.
Definitely right-tailed. And here's the thing, we're going to talk more about this later. There are certain things that are almost always right skewed. Financial data is very likely to be right skewed. Consumer goods, and you could think of this as a good in a sense, okay, a commodity, apartments are clearly right skewed, clearly right-tailed. If you were uncertain, what would you look at?
The median of inside the box.
So let me ask you a question. Notice there are two lines here, a green line and a red line. Which do you think is the median and which is the mean, and why?
Mean is probably green.
Green.
What happens to the mean when the tail appears? You guys didn't see my great animation? I put this animation in and everything. Oh, I'm so disappointed. Okay, it gets, well, never mind, I'm not going to show it, I don't have time. What happens is that the mean gets pulled out towards the tail. Remember the Mr. Burns example, right? What was the average? 100. Because there was an outlier. It's pulling it towards, right? The mean gets pulled towards anything that causes the data values to kind of become skewed like this. So this is the mean, okay, and that's the median. And you have to know that because it makes a difference when you're talking about data sets. That's an important distinction. So this is one sign. I could make a box plot also, right? And if I made a box plot, and I'll do that because I can do that super quick, the box plot will reflect what I'm seeing here. And this is actually a good data set to look at to see skew, okay? So you can see that, a little too scrunched. So you can see what's happening. When you have a right skewed data set, the values are bunched up at the left, and you're seeing this here. 25% of the data values are bunched up, right? This is the first quartile, and this is the median, right? The second quartile. Then it's getting stretched out. So between the 50th percentile and the 75th percentile is contained in here. So first, you see the asymmetry in the location of the median, right? You see the asymmetry in the length of the whiskers, all right? And then you're seeing these outliers. And again, these aren't actually outliers. These are really outliers in name only. Okay, this is a little separated, but it's not that separated. It's only separated because I don't have a large enough sample, okay? But that's how you determine it. So this is clearly right skewed. We don't have any outliers. Again, these three appear as outliers. They're not outliers. They're part of a long tail. You do have one gap, but if I rebin to this, okay, making a slightly larger bin size, that gap would go away. An outlier has many bins, okay? It's separated. It's an outcast. This guy's still on the outskirts. Okay, so we can fill in a few blanks here.
Professor, got a question.
Yeah.
So I'm trying to do the box plot. I tried doing it, and it didn't appear. It appeared vertically instead of horizontally.
Yeah, you got to know the magic button to push right here.
What's the magic button? Oh, horizontally.
Yeah,
All right.
yeah. I don't know why the default, well, actually, I do know why the default is that way. But yeah, when you're looking at a single variable, it's much easier.
All right. Thank you.
Very good question. Thanks. Okay. So now we can fill in some blanks. I'm going to go back to the PowerPoint now and fill in some of these things. So let's see. That part's good. We plotted the data. Let me go ahead and cut and paste that in here. Here I am. Okay, and then size that. And now we're ready to do our description, okay? We'll do the center and the spread in a minute. And I'm just going to copy and paste this. So unimodal, right skewed, no apparent outliers. Okay, and we're done. Okay, center and spread, right? Last two things we need here. So,
Oh, Professor.
yeah, shoot.
I have a question. So when I did the summary statistics on it, I clicked the mode just for fun, and it comes up as multiple modes.
That's right. And the reason why is, so it's a stupid reason why, and this is why we don't use the mode. When it computes the mode, it looks at every single value, okay? And it's reporting the one value that occurs most commonly, and we don't want that, okay? And that's why we never do the mode. And I'll tell you what, that's kind of a minor point. Let me finish this up, and if you want a little more details, I'll come back to that, okay?
Okay, thank you.
Sure. Okay, so summary stats. And after a while, I mean, you know, one of the things I like about StatCrunch, and there are things I don't like about it, but one of the things I like about it a lot is it's really easy to use. So remember, skewed, I'm not going to use the mean. I'm going to use the median. And I'm not going to use the standard deviation. I'm going to use the IQR. And again, because these things are insensitive to the skew. They're not affected by it. And click compute. And they did the wrong thing. Here we are. Too many windows. All right. Pull this table over here. And there we are. So
I don't see your screen anymore.
Oh, you know what? I clicked off when I did that. Thanks for letting me know. I appreciate that. I'm talented like that. Okay. Everything good?
Yes.
Okay. So our median's 875. Our IQR is 305. That's pretty big range, okay? And so we go back and enter this. So our center is the median. And I'm just going to copy and paste this because it's easier, not to waste time. And the median we said was what, 875?
Yeah, 875.
Thank you. And then the IQR was 305?
Yes, 305.
Nice to know I haven't lost all the brain cells yet. Okay, there we are. Excellent. Okay, and now we're done. I can put it all together, right? For the grand finale, the data is unimodal. No, it's not. It's right skewed unimodal. Let me cut and paste this though. So see, this is why it's so nice. On the exam, you can just copy and paste this as a script. I don't mind, okay? Okay, the center is given now by the median. Just add a DI, which is 875. You can write out interquartile range, but anyone that does any statistics at all that could even understand what you were talking about, they will know what IQR is, okay? And that's 305. In Fort Pitt, that's it. Alrighty? So, you guys get a super nice bonus for showing up. On the exam, I'm going to give you a problem from the iPad's data. Notice, if you look at the iPad's data, there's 4 different costs, okay? Let me pull it up just really quick to show you. This won't take but a minute. There are 4 different costs, okay? There's a cost for in-state, on-campus, out-of-state, on-campus, in-state, off-campus, and out-of-state, off-campus. I'm going to give you one of these 4, all right? For the exam. Which one? Who knows? They're all pretty much the same, really. They don't differ a great deal. The details differ, okay? But that will definitely be one of the exam problems. Notice if you know what you're doing, this really doesn't take that long, right? You plot the histogram, you screw around with the bins a little bit. It doesn't take a couple of minutes to do, you know. You get the number of modes, you get the shape and the outliers almost immediately, okay? And the center and spread, it took me all of 10 seconds to compute that, all right? The hard part is when you're not clear about the shape, then you have to make the box plot, okay? That's the time when it takes a little bit more work, but what is that, 3 minutes or so, maybe most, so. All right, I hope that helps. Is this, now how is this? Is this kind of like clear what I did? You think you can go back and watch the video and kind of make sense of this, or does it still seem like black magic?
Once I watch the video, I'll be better off.
And this is why I say if you have your laptop open and you can follow along, it helps. And it's not a bad idea because sometimes what happens is things happen on your laptop that don't happen on mine. And then I can kind of help you do a little bit of troubleshooting, okay, and stuff like that. But yeah, hopefully it will help. And if you have any questions, of course, I'm just, a simple text away.
How do you get those summary statistics again? I'm sorry, I just blurred out for a second.
Okay,
So-
stats, summary stats, bingo. Okay, in fact, I'll even do one for you. And I mean, and if you want, if you're really lazy, you can do them all. But the problem is, I don't think it gives you everything you need necessarily. That's why I got off of screen sharing. I hit that guy.
Maybe you can do it by group by.
Don't do group by yet. Group by does something different. Okay, group by does something, but don't do it right now. Okay. Yeah.
Okay.
Yeah. If you follow what I did, money back guarantee. You can't go wrong. All right. I think what it doesn't tell you when you hit the default, it doesn't tell you the IQR. You could actually compute it from this, but I mean, why compute something when a computer can do it, right? I mean, to me, it just, I don't want to waste time doing that. So,
Why
what's that? Why do what?
reinvent the wheel?
Exactly. Yeah, right. Computer won't make a mistake, and it'll do it faster than you. So, yeah. All right, cool beans. I think we're at the end, right?
Yep.
Okay, perfect. And if you have any other questions, I'll hang around and I'll answer them. And if not, you're free to leave of your own recognizance. All right, thanks for showing up, guys.
Thank you, Professor.
All right,
Thank you, Professor.
Yep.
Thank you.
I'll see you later on.
Good day.
You too, thank you.